Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
For this example, we're given two identical rectangles here with the exact same area, but they're just sitting in different orientations here in our XYZ plane. So one of them is sitting flat along the XY plane and one of them is sitting flat along the XZ plane. And we can see that we have a uniform magnetic field in this entire area, and it's pointing with a 35-degree angle to the Z axis. So it's uniform everywhere. And what we want to know is what is the ratio of the flux through the XZ surface to that of the XY surface. So we can make an early prediction here and try to figure out which of these will have more flux since they're identical. And since we can see that the magnetic field here is more parallel to the normal of the XY surface than it is to the normal of the XZ surface, that the XY flux is going to be greater than that of the XZ, and this will be less than 1. So we can sort of intuitively check our answer based on our little prediction here at the start. Now, if we remember the expression for the magnetic flux in a constant magnetic field, it's just going to be B times A times the cosine of the angle between the surface normal and the magnetic field. So in this case, B is the same everywhere. A is the same for both loops. And the only thing that's going to change is the angle between the magnetic field and our area normals. So if we're looking at the flux of xz over the flux of xy, well, for xy, let's look at that one first because it'll be a little easier. We can see that the surface normal there, if I were to draw it over here, makes an angle of 35 degrees with the magnetic field, right? Because the surface normal for xy just points in the z direction. And of course, b by definition makes a degree or an angle of 35 degrees with the z direction. So for the xy flux, we know it's just going to be b times a times the cosine of 35 degrees. Now, for the xz one, it's going to be a little different. We'll draw that out too. The surface normal is going to point something like this, right? It's perpendicular to that surface. And the magnetic field is going to be pointing up like this. Where the 35-degree angle is right here between the z-axis and b. So since z and y make a 90-degree angle here, the angle between the surface normal, which points to the right here, and b is actually this angle, which is going to be 90 degrees minus our 35 degrees there, which will just be 55 degrees, I believe. Yeah. So down here, again, we have the exact same field and area, but we have a cosine of 55 degrees. Okay, so our b's and our a's cancel out because they're the same on top and bottom. And we're just left with the ratio of the cosine of 55 to the cosine of 35. So if we plug that into our calculators, we will see that the ratio of the flux through the xz square and the xy square is going to be 0.70. So does this match our prediction? Sure does. So just like we thought, the flux through the xy rectangle is going to be greater than that of xz because its surface normal is more parallel to the magnetic field.